All right. I just wanted to go through the solutions to the problem sets 1.2, 1.3, and 1.4. Many of you have already moved on from those, and that's fine. But let me give you my solutions to each of these, and I'm just gonna run through these quickly. Okay. You can pause, you can rewind, you can slow things down if you need to, but I'm just gonna walk through them real fast. So this is problem set 1.2. The task 1 says the raw data to the left show the type of cranberry sauce that a random sample of nearly 1,000 Americans said is typically served at their Thanksgiving meal. Part A asks us to use a pivot table to create a frequency and relative frequency distribution for the data. Okay, and then we want to create a frequency bar graph. So let's do it. So there's my frequency distribution. If I want a relative frequency distribution, then I can insert a new pivot table. And all I need to do is change the count here to percentages. So I'm going to click on count under the values menu, click on value field settings, and show values as percent of grand total. So that's it for part A. We want a frequency bar graph. This is a frequency distribution. This is a relative frequency distribution. Since we want a frequency bar graph, I'm going to use the top one to insert my bar graph. Now I'm done. On to the next one. Little over 900 randomly selected American citizens were asked what region of the country they live in. Their responses are recorded to the left. We are asked to use a pivot table to create a relative frequency distribution. This time we're not asked for a frequency distribution, so we just need the relative frequency distribution. And then we want a relative frequency bar graph. So here we go. Okay, and then again we need to make this percentages since it's supposed to be a relative frequency distribution. So we've got that, and now I'm just going to insert my bar graph, and I'm done with that one. On to the next. How would you describe where you live? Okay, we want a frequency distribution and a frequency bar graph. Okay. This time we just want a frequency distribution, not a relative frequency distribution. So we're done at this point. Insert our bar graph. And on to the next one. Okay, this one's a little different. We don't have raw data this time, right? We have a frequency distribution. We're starting with a frequency distribution. It says, this is supposed to be favorite Pokemon. Okay, use a pivot table to create a relative frequency distribution from the frequency distribution to the left, and then create a frequency bar graph. Very well. Your wish is my command. So let's insert a pivot table. Maybe I'll put it right here underneath the first one. Now, this is a little different. We're going to drag favorite Pokemon to rows. But now if I drag favorite Pokemon to values, it's just going to say that, hey, Bulbasaur appeared in this list right here. Bulbasaur appeared one time. And Charmander appeared also one time in this list right here. But that's not what we want. We don't want it to count up how many times Pikachu appeared in this list. We want to count up how many times Pikachu appeared in this list. So instead of dragging favorite Pokemon to values, I'm going to drag count to values. Now these numbers look a little bit different from these ones, but that's just because the values here have been arranged in alphabetical order. If we wanted to put them in this order, we could do that. You just need to click and drag these around. So Pikachu, Charmander. You weren't tasked to do this, so You don't really have to, but Eevee, Bulbasaur, Squirtle. Okay. What I do need to do, though, is this is supposed to be a relative frequency distribution. What I have right now is a frequency distribution. So let's change show values as percent of grand total. And now that part's done. So I'm done with part A. Part B asks for a frequency bar graph. This is a frequency distribution. This is a relative frequency distribution, right? So a frequency bar graph would be this guy right here. So insert bar graph, and we're on to the last one. Makeup brands. Okay. We're asked to make a relative frequency distribution and then a relative frequency bar graph. Very well. Let's insert a pivot table. And same thing on this one. We're not starting with raw data. We're starting with a frequency distribution. So we're going to drag brand to rows. But then instead of dragging brand to values, which is just going to tell us that all of those brands occurred once, we're going to drag count to values. And now that's correct. And if I wanted to, I could rearrange these so that they're in the same order as this one, but I don't really care about that. I do need to make these percentages, though. And now I can insert my bar graph. This one's supposed to be a relative frequency bar graph, so I used the relative frequency distribution for that. And I'm done. So that'll do it for problem set 1.2. I saved my work. Now I can exit out of that. And it should be saved, right? If I open it back up, all of my work is still there. Okay. Very nice. On to 1.3, problem set 1.3. Let's take a look. Here's where things maybe got a little more difficult for some of you. Here we're supposed to, it says use a pivot table to create a frequency distribution for the number of goals scored. Do not group the data into classes. Okay. Insert pivot table. Drag goals to rows, goals to values. Now, when you have numerical data, you do have an additional step that you need to do, which is you need to change sum to count. So we're going to click on this variable, go to value field settings, change sum to count, and that should be correct for part A. Part B says to create a frequency histogram. So highlight the table, insert a bar chart, and there's also an additional step here, which is that we need to make these bars wider because this is a histogram, and histogram shouldn't have any gaps. So unlike the bar charts in problem set 1.2, these bars need to be wide. So I'm going to click the bars. Notice that they're all highlighted. And now I'm going to right click them. And then I can go to Format Data Series and set my gap width down to like 2% or 3% or something like that. And that looks good. On to the next. This time we want a relative frequency distribution. So we'll start off by inserting a bar chart or a pivot table. Number of children, change sum to count. But now I need to make these relative frequencies. So I'm going to change the counts to percentages. So back to value field settings, show values as percent of grand total. And that's it for part A. Now I can highlight this, insert a bar chart, and we just need to make the bars wider. Format data series, set the gap width down to 2% or something like that. Now there is a little problem with this one. Oh, let me make the gap width like 3% or something so that I get a nicer picture. Now there is a problem with this one because it says in part A, it says make sure to display the empty classes. And you'll notice that we do have some empty classes. There should be, it goes 0, 1, 2, 3, 4, 5, 6, 8. It skips over 7. And then it goes from 8 to 10, so it skips over 9. And then it goes from 10 to 15, right? So it skips over a bunch. Okay, so we've got to do something here. If you're going to display the empty classes, the easiest way to do that is to group into classes. Okay, So we'll group. And now I still want the class width to be 1 so that each observation is its own class. And I want to start at 0, right? So I'm including 0. I need to change the ending point to 17 because for whatever reason, Excel is going to group the last two bars or the last two values together into one bar. And that's going to mess up the grouping of the grouping into classes, right? Where I want each observation to be its own individual class. So if I add 2, that resolves the issue. Now you may look at this and say that didn't change anything because I'm still not seeing the missing classes. But if we right click again, then we can go to, I always forget if it's field settings or pivot table options, but I think it's field settings. So I'm going to go to field settings and then layout and print and show items. No, that's not what I wanted. I want show items with no data. And then all of those missing classes show up. I don't need this class, 16 to 17, because the largest number in the class, or the largest class was the 15 class. So I don't need this one. I don't need anything more than 17. And I don't need anything less than 0. So let me just click this little drop down menu and then I'm going to hide those ones. And now that looks good. Optionally, you could change these labels. So instead of being 0 to 0, it's just 0, right? So you just click on a cell and then type in the label that you want and hit enter. And then you can change all of them. Whoops. And it also changes the labels on the graph, which is pretty nice. Notice the drastic difference in the shape of the distribution once you display the empty classes. This is why it's so important to display the empty classes, because if you don't, then you might think that something is symmetric when really it's skewed right, like it is in this case. Okay, on to task 3. This is one where we're asked to make 2 different pivot tables from the same set of data, and that's going to be a problem because the pivot tables will be linked if we try to make it from the same column. So before I even do anything, I'm going to start off by making a copy of this data set. So I'll select the column, right click it and say copy, and then I can paste it into another column. Now I have 2 copies of the data set. I'm also going to insert a blank column just because I think it looks neater. Okay, so for part A, I need a pivot table. So height and height. I need to change sum to count. And now it says group into classes, start the first class at 160 and use a class width of 10. So I'm going to highlight a row, right click it, and go to group. I want to start at 160 and use a class width of 10, which is already its default settings. I'm going to say OK, and that's it for part A. Part B says to use a pivot table, group into classes, but we want the classes to be different. This time we want to start at 1. I think the instructions originally said 160, but if you use a class width of 5, then it's going to start at 165. So we'll start at 165 and use a class width of 5. I already used the first column to make this table. If I use that same column to make my next table, the tables will be linked. And so when I change one of them, it'll change the other, and that's not what I want. So I'm going to use the other column to make my pivot table. Height, height, sum, count, group, 165, group by 5s. And that's it for part B. Then part C just says to create frequency histograms for each of these distributions, and that's easy enough. Highlight one of them, insert a bar chart, get rid of the total, and make the bars wider. Okay, same with this one. Highlight, insert, get rid of the total, make the bars wider. that's it for that one. On to the last. This time we want to make 3 pivot tables. So I'm going to make 2 copies of this. Paste. Let me insert a couple blank columns. Then I can copy and paste again. And here we go. First pivot table. Put it right there. Let's change sum to count. Group into classes. It says to start the first class at 2,000 and use a class, or 2,000 use a class width of 10,000. Well, those are the default settings, so that's good. It also says to make sure to display all empty classes. You'll notice, for example, that there's an empty class between the 152 and the 172. So let's make sure that gets displayed. We go to Field Settings, Layout and Print, and Show Items with No Data. And that's that. I can hide the less than 2,000 and the more than 182,000 rows. And that's that. If you want zeros to show up here, you can put them in there. It's not necessary, but to do that, we go to Pivot Table Options, and then for empty cells, show 0. And then the zeros pop up there. Again, that's optional. You don't have to do that if you don't want. Let's make the next one. Attendance, change sum to count. Group. This time we want to start at 2,000 and use a class width of 20,000. So I'm going to group by 20,000. And I don't think there are empty classes on this one, but just to be safe, we can show items with no data. And yeah, it doesn't make any changes except that it adds these annoying rows, which I'm going to turn around and hide now because I actually don't want to even see them. On to part C. Let's put this one right here. Attendance, change sum to count. Group. This time we want start at 2,000, class width of 5,000. Okay, 5,000. All right. And let's display the empty classes. So field settings, layout and print, show items with no data. And then, yeah, sure enough, we have some gaps, right? So it's a good thing we displayed those. Let's hide the less than 2,000 and the more than 17,700. And then we're good with that one. We weren't asked for any histograms on this task, so we're done there. And that's it for problem set 1.3. Last but not least, let's look at problem set 1.4. Okay. Cholesterol levels were collected from a sample of 14 patients 2 days after they had a heart attack. Construct a box plot and use it to estimate the quartiles. All right, I'll select the data. Box plots are super easy. They're here under the histogram tool. And that's all we have to do for that. Now, this is optional, but personally I don't like the fact that this starts all the way at 0 because there's a lot of blank space down here that just seems unnecessary to me. So to get rid of it, I'm going to select the axis and then right click it, and I can format axis and make the minimum start at like 150 or something. That seems like a more reasonable starting point to me, and it makes for a better looking graph. Now if I want to estimate the quartiles, then I can add some data labels, and so then I can see that Q1 is 233.5, that Q2 is 273, and that Q3 is 288. Some of you made the box plot beautifully, but you forgot to put in the labels for Q1, Q2, and Q3. Anyway, that's it for task 1. On to task 2. Same instructions. Construct a box plot. Use it to estimate the quartiles. Very well. Insert box plot. Ooh, we got a couple outliers this time. And this time I think starting at 0 is maybe a little bit more reasonable. That seems like a decent looking histogram as is. I might add the data labels just so that I can estimate the quartiles like I'm asked to. Q1 is 90.75. Q2 is 139. And Q3 is 168.5. And that's it for task 2. On to task 3. Okay, this one says 100 randomly selected individuals took an IQ test. Their results are recorded to the left. Create a box plot. Use it to identify any outliers and to determine the shape of the distribution. Okay. Let's insert a box plot. Ooh, I want to put this where we were asked for it, so I'm going to drag this back up and put it in its rightful place. Maybe I can start at 40 or something instead of 0. That looks a little nicer. There are no outliers. Maybe I can even start at 50, right? But no outliers. The outliers would be dots above or below the whiskers. And I don't see any of those. So any outliers? Nope. What's the shape of the distribution? Well, this box plot looks pretty darn symmetric to me. So I would say symmetric. I don't know if it's bell-shaped or uniform. I think it's impossible to tell that from a box plot. To know if it's symmetric or to know if it's bell-shaped or uniform, we'd probably have to look at a histogram. But we can definitely say it's symmetric. Part B says, now create a histogram for the data, group into classes with a starting point of 50 and a class width of 10. Does the shape of the histogram match the shape of the box plot? Okay, well, so some of you are very tempted at this point, since we know about some of you are very tempted to use this histogram tool because you're like, we have this histogram tool now, so I'm gonna use that, right, to make my histogram. The problem is, the histogram tool in Excel will not make the histograms correctly. You can adjust like the class widths and stuff, but this is very subtle. But if you look at the first class, it has a square bracket on the left, whereas the second class has a rounded parenthesis, and so does the third and fourth and fifth. So Excel counts the first class differently than it counts the other classes, and it makes for a subtle difference, but an annoying difference. And so I do not want you to use the histogram tool in Excel. Instead, you should make histograms the way that we've been making histograms, the way that we made them in section 1.3, which is going to require us in this case to first insert a pivot table. Maybe I can put it right here. Change sum to count. And group into classes. We want a starting point of 50, not 58, and a class width of 10, which is already its default setting. We also should display the empty classes, but I don't think we have any. 50, 60, 70, 80, 90, 100, 110, 120, 130. No empty classes. So then we can insert the histogram. Not using the histogram tool, but using the bar chart tool. Okay? And we should make those bars a little bit wider. And that looks good. Now, the shape of this histogram is bell-shaped, right? Which is a symmetric distribution, right? So we could say it's bell-shaped, which is symmetric, right? And so to answer the question, does the shape of the histogram match the shape of the box plot? Yes, the shapes match. As we would expect, right? Okay, on to task 4. Again, part A wants a box plot. Use it to identify outliers. Okay. Let me scroll back up. And we'll insert our box plot. Let's start at 10 maybe instead of 0. We could even stretch this out a little bit. So any outliers? Well, yeah, there are 3 of them, it looks like, on the top. So let's add some data labels so I can see what those are. 21, 21.3, and 22. Shape of the distribution. Well, the top whisker looks longer than the bottom whisker. So I would say that this is a skewed right distribution. It looks skewed right to me. To double check that, we could of course make the histogram. It says group into classes with a starting point of 12 and a class width of 2. Okay. Insert pivot table. Let's put it right here. Oh, I just messed up. Let me start over. Insert a pivot table in the existing worksheet right there. Okay. Change sum to count. And group into classes. Start at 12, it says. Use a class width of 2, it says. Okay. And now we'll insert our histogram, really a bar chart. Make the bars a little wider. And now that's a nice looking histogram. I think it's skewed right. Definitely the histogram looks skewed right. So does it match the shape of the histogram? Or does the shape of the histogram match the shape of... Yes, they match. And that's that. I was going to say, you know, some of you may have gotten some of your answers wrong, even if I gave you like full credit. It's just hard to catch every little mistake that you might make. So, you know, double check your work and see how you did. And if anything's amiss, feel free to correct it. If you got less than full credit, feel free to correct your work and resubmit it. But that'll do it, I think, for this video.